Good day everyone, welcome. Today we'll be discussing on the topic permutation. Before going into permutation properly, we'll be revising a term known as factorial. Now the factorial of a number is the product of all positive integers from 1 up to that number. It is written using the exclamation mark. For example, n factorial will be equals to n times in bracket n minus 1 times in bracket n minus 2, or going so on and so forth to 3 times 2 times 1. 0 factorial will be 1, 1 factorial will be 1, 2 factorial will be equals to 2 times 1, 3 factorial will be equals to 3 times 2 times 1, 4 factorial will be equals to 4 times 3 times 2 times 1, and 5 factorial will be equals to 5 times 4 times 3 times 2 times 1. So basically a factorial of any number is when we multiply that number, stepping it one or removing one from it, or we get till we get to 1, or we multiply from 1 to that number. So in this same case, the factorial of 6 will be 1 times 2 times 3 times 4 times 5 times 6, or 6 times 5 times 4 times 3 times 2 times 1. Now permutation. What is permutation? A permutation is an arrangement of items where the orders matter. That's we are arranging items and we are putting into consideration the order of our arrangement. A permutation of n distinct objects taking arrow at a time is an arrangement of arrow out of the n objects with attention given to the order of the arrangement. Simply means that when we have n number of items, let's say 10 items, and we are trying to arrange 3 items out of the 10 items with consideration to the order, that will be written as n permutation arrow, which should be equals to n factorial divided by n minus arrow factorial. We have some example. Now it states evaluate each of the following: A 8 permutation 3, B 7 permutation 5, C 9 permutation 2, D 5 permutation 5. Now for our solution, A 8 permutation 3, and from our formula we know that n permutation arrow is n factorial divided by n minus arrow factorial. So this will be equals to 8 factorial divided by 8 minus 3 factorial, which will be equals to 8 factorial is 8 times 7 times 6 times 5 factorial. Now the reason we are not continuing this is because our denominator, which is 8 minus 3, is also 5 factorial. So we can easily strike out 5 factorial from our numerator and our denominator, and we'll be left with 8 times 7 times 6, which is equals to 336. For B, we have 7 permutation 5, which should be equals to 7 factorial divided by 7 minus 5 factorial, which should then be equals to 7 times 6 times 5 times 4 times 3 times 2 factorial divided by 2 factorial. 2 factorial striking out, we are left with 7 times 6 times 5 times 4 times 3, which is equals to 2520. Now for C part, we have 9 permutation 2, which should be equals to 9 factorial divided by 9 minus 2 factorial, which will then be equals to 9 times 8 times 7 factorial divided by 7 factorial. Our 7 factorial in our numerator and denominator is going to cancel out, so we'll be left with 9 times 8, which is equals to 72. And for our final example here, which is D, that's 5 permutation 5, to be equals to 5 factorial divided by 5 minus 5 factorial. So it will be equals to 5 factorial divided by 0 factorial, and recall that 0 factorial is equals to 1. So this will be equals to 5 times 4 times 3 times 2 times 1, which is equals to 120. We have another example that states that how many ways are there of arranging 3 different jobs between 5 men where any man can do only 1 job. Now the possible arrangement is 5 permutation 3, that is we are choosing 3 men for a possible pool of 5. This will be equals to 5 factorial divided by 5 minus 3 factorial, which should be equals to 5 factorial divided by 2 factorial, which is equals to 5 times 4 times 3 times 2 factorial divided by 2 factorial. Our 2 factorial in our numerator and our denominator is going to equate r. So we are left with 5 times 4 times 3, which is equals to 60. Our next question states that in how many ways can 8 people be seated in a bench if only 3 seats are available? It's still the same permutation problem because we are arranging 8 people with our options being 3. So it will be 8 permutation 3, which is equals to 8 factorial divided by 8 minus 3 factorial. 8 minus 3 is 5, so it will be equals to 8 factorial divided by 5 factorial, which is equals to 8 times 7 times 6 times 5 factorial divided by 5 factorial. Our 5 factorial in our numerator and denominator is going to equate r, so it will be equals to 8 times 7 times 6, which is equals to 336 ways. Our final question states that if the mathematics department of a college has 5 members of staff and they are to pose for a photograph by standing in a row, how many different arrangements are possible? Now we are going to be arranging 5 people and the order is also 5. It's going to be 5 permutation 5, which should be equals to 5 factorial divided by 5 minus 5 factorial, which is equals to 5 factorial divided by 0 factorial. We know that 0 factorial is equals to 1, so 5 factorial will be equals to 5 times 4 times 3 times 2 times 1, which is equals to 120 ways. Here are some exercises on this topic, and for more insight on the topic you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.